All right, welcome back to Die Hard American Metal. Today, we are going on a quest. We're diving headfirst into the super high-stakes game of laser welding stainless steel. And listen, this is not just about melting two pieces of metal together. This is about chasing absolute, undeniable perfection. So let's fire it up and get started. This right here, this is the Holy Grail. I want you to just imagine that for a second. A weld so clean, so perfect, it comes out of the machine looking like it's already been polished for the showroom floor. No grinding, no cleanup, nothing. Just pure, beautiful strength. That's the prize, and that's what we're after.
So, how in the world do we get there? Well, the path is called autogenous welding. And what that means is we're using only the laser's raw energy to fuse the metal. There's no filler wire, no safety net to cover up your mistakes. It is the ultimate test of your skill, your precision, and your process control.
Now, right out of the gate, our biggest opponent is the material itself. Stainless steel is an amazing alloy for sure, but the second you hit it with the kind of energy a laser puts out, it starts to fight back. And to win this fight, you have to understand your two biggest enemies, the metal itself and the insane heat you're putting into it.
Okay, check this out, because this is where stainless gets really stubborn. First, it has really low thermal conductivity. In plain English, it holds on to heat like a sponge. The heat doesn't spread out, it just builds up right where you're welding. And to make things worse, it has a high thermal expansion rate. It swells up 50% more than carbon steel. You put those two things together, and you've got a perfect recipe for a warped, distorted mess.
So, with all that heat and stress, we come face to face with the #1 villain of this whole process, solidification cracking. See, as that molten weld pool cools down, little impurities, we're talking things like sulfur, can form these weak, liquid-like spots between the metal grains. Then, as the metal shrinks, all that stress just tears the weld apart from the inside out. It's an absolute nightmare and a catastrophic failure. To beat cracking, it all comes down to controlling exactly how the metal solidifies. You've got two paths. There's the safe path, called FA mode, where impurities get locked up safely inside the grains. Then there's the dangerous path, A mode, where the impurities get shoved to the edges, creating those weak spots we just talked about. The crazy thing is, the super fast cooling of a laser can actually force the steel into that dangerous A mode, so our entire mission is to engineer the process to guarantee it solidifies in FA mode every single time.
So, the deck is stacked against us. How do we fight back? Well, we fight fire with a highly controlled beam of light. The laser is our weapon of choice, and mastering it is the key to building the arsenal we need to forge perfection.
Now, a laser basically has two main ways it can weld. First, you've got conduction mode. Think of this as the artist's touch. Low power, a nice and calm weld pool, and you get a beautiful finish. Then you've got keyhole mode. This is the brute force. We crank the power way up, the laser literally vaporizes a tunnel into the metal, and you get insane penetration and strength. The real genius is knowing how to blend these two to get the best of both worlds.
Okay, that's all great in a perfect world, but you know how it is on the shop floor. Parts are never perfect. So what do you do when you have a tiny but very real gap between your parts? A straight laser beam might just blast right through it, and you've got nothing. Well, get ready for this, because this is the secret weapon. It's called beam wobble. Instead of just a single point of light, we make the laser beam dance around in a tiny circle or a figure eight hundreds of times a second. That rapid stirring motion acts like a microscopic ladle, grabbing molten metal from both sides and pulling it together to bridge that gap perfectly. It's not an exaggeration to say this technique is a complete game changer.
All right, so beam wobble gets you in the game, but if you want to play in the big leagues, if you want to achieve true perfection, you need the pro-level moves. These are the techniques that give you total, absolute control over every aspect of the weld.
First up, we have to build an invisible fortress around our molten weld pool. That's our shielding gas. And this is way more sophisticated than just blowing some air on it. Argon is your workhorse. It's heavy and it pushes the atmosphere away. Nitrogen can actually become part of the weld in some grades, making it stronger. And adding a little bit of helium, that's like strapping a turbocharger to your laser, letting you go faster and deeper.
But here's a secret that separates the pros from the amateurs. It's not just what gas you use, it's how you deliver it. You can't just blast it on there. You need smooth, gentle, what we call laminar flow. You have to think of it like gently laying a perfect, undisturbed blanket of gas over the weld. The alternative is a turbulent storm that actually sucks in the air you're trying to keep out.
And just how perfect does that gas blanket need to be? Well, look at this number, 50 parts per million. To get that beautiful mirror silver finish with zero discoloration, you have to get the oxygen level down below 50 ppm. We're talking about a level of purity that is just incredibly demanding. So, let's bring it all together. No filler wire means zero room for error. And that leads us to one of the fundamental truths of this process. The fixture is the welder. Your tooling, the clamps holding the part, has to be surgically precise. It needs to hold that gap to less than 1/10 of a millimeter, while huge copper blocks, called chill blocks, are right there, sucking the heat out of the part as fast as possible to keep it from turning into a pretzel.
Okay, so you've got your laser dialed in, your gas is perfect, your fixture is a masterpiece, you're ready to make a perfect weld. But the battle isn't over. Now you have to fight a war on two fronts: defeating the defects that can scrap your expensive part and protecting yourself from the invisible dangers of the process itself.
Think of this as your field guide for that war. Got porosity, those little bubbles in the weld? Your keyhole is probably unstable. Use a figure-8 wobble to stir it up and let the gas escape. Still getting cracks? You need better material, a laser-grade steel with ultra-low sulfur. Seeing that ugly rainbow heat tint? Your gas shielding isn't cutting it. You need better flow, maybe even a trailing shield to protect the weld as it cools. This chart right here is pure gold.
But you know, we can see all of those things. We can see a crack, we can see porosity, but there's another enemy in this process. One you can't see, you can't smell, and you can't taste. So what is the invisible killer we're up against?
Here it is, Hexavalent Chromium. And we've got to be serious for a minute here. When that incredibly powerful laser beam hits the stainless steel, it vaporizes the metal, including the chromium. And that process can create this fume, which is highly toxic and a known carcinogen. This is not something to mess around with. It's a serious hazard that demands serious respect and engineering controls.
So this is your defense system. And it's not just one thing, it's a multi-layered approach. You need fume extraction right at the source, sucking those fumes away the second they're created. You need powerful ventilation, scrubbing the air in the entire enclosure. That air has to go through HEPA filters that can capture these tiny metal particles. And for anyone doing maintenance, a P100 respirator. Every time. No excuses. Period.
So, after all of that, the tricky metallurgy, the complex physics, the serious safety concerns, you have to be asking, why would anyone go through all this trouble? Well, this is why. Look at that chart. We are not talking about a 10 or 20% improvement here. We are talking about a 10-fold, 1,000% increase in speed over traditional TIG welding. Now add in the fact that there's no grinding or cleanup, and you're looking at one of the biggest productivity leaps in modern metal fabrication.
So there you have it. The science, the strategies, the secrets. That's the playbook for achieving a perfect stainless steel weld. This isn't just some theory. This is the absolute cutting edge of manufacturing happening right now. We've just handed you the keys to the kingdom. The only question left is, are you ready to go out there and engineer perfection?